All right, gang, in this video we're going to talk about how to determine what the graph of an inverse looks like if you just have the graph itself. Uh, so there's a lot of different things we're going to do with inverses in this section. Verifying them, determining them algebraically, doing the whole horizontal line test. This particular one, you are given the graph of the function, in this case x to the third plus 1, and you are asked to graph the inverse of that function. And so there's three things that I just want you to keep in mind as you're going through to do this. And earlier I had mentioned in the video that a function and its inverse graphically are reflected across the line y equals x, the blue line in this case. So you can imagine that you're just going to be taking that graph and flipping it right across the line y equals x. Well, to make it easier, I want you to do first just switch the x and y coordinates of the values that you can see in the original graph. Remember, the domain of one is the range of the other and vice versa. So there's 3 points on here that are kind of easy to find. First is -1, 0. I just want you to plot the point that's opposite that, the one where you switch the x and the y, 0, -1. And if you take a look at that, you can see that it's a mirror image right across that blue line. The second point is at 0, 1. Switch the x and the y and plot it, and that would be 1, 0. And the third point is 1, 2. Switch the x and y to get 2, 1. And if you take a look at it, all three of those points are mirror images right across that y equals x line. Second thing to keep in mind is that if the original graph ever touches the line y equals x, then the inverse is going to touch that line at the exact same spot. So it touches right there, so we know that the inverse is also going to touch right there. And the last thing is just remember that it's a mirror image, and you're going to draw a smooth curve through those lines so that it's symmetric about the line y equals x. And it is going to look like that. So that's how you graph the inverse of a function if all you have is the graph itself. That's it. Let's go.